Alright, I'm going to go over Chapter 3 here. This deals with the OSI model, but mainly the application layer of the OSI model and of the TCP/IP. Very similar between the OSI and TCP/IP model is the application layer. So the concept talked about in this chapter can carry over in between both. The application layer is what's closest to us as humans. Everything that we do on the network, if we're going to send an email, we have to use some type of application. If we're going to surf the web, we have to use some type of web browser. So we're using some type of application. So a lot of times you'll hear this as called the human interface layer. So what we do here at this application layer is we take our message that we want to send as humans. Maybe it's an email message. So we take our English language, our text, and that application layer transfers it into something that the computer can represent through whatever type of application you'd be using, whether it be, say, Hotmail or Outlook or something like that. Prepares that human communication for transmission over that data network, sends it on down to the presentation layer. This slide here kind of shows the relationship between the OSI model and the TCP/IP. You can see that in the TCP/IP model, the application layer accounts for the top 3 layers in the OSI. So at the OSI, we have application, presentation, and session. If you watch that email video on how that email gets processed down the line, in the application layer over there in the TCP/IP, that would take care of all 3 of those things. Some more specific protocols or services that happen on that application layer are DNS, or domain name system, and I'll show you an example of that here in a little bit. Hypertext transfer protocol, that's HTTP when we're surfing the web. Simple mail transfer protocol, SMTP, sending emails back and forth. Post office protocol, POP, that's also with email. And DHCP, or dynamic host configuration protocol, that's how computers get IP addresses. All of those services, again, very common services that you might have heard of before. And this slide here shows some of the application services, again, that run on our networks. And these all happen at the application layer. We have DNS, Telnet, which would allow us to connect to a remote computer, email, DHCP, web server, FTP, that stands for file transfer protocol. If you ever download a file or something from a website, you would more than likely download it over the FTP protocol. Each one of these services may have different types of protocols associated with it, or different port numbers, as we'll learn later, associated with it. For example, a web server, you may be using HTTP, the Hypertext Transfer Protocol, or you could also be using HTTPS, which is the secure version of that. Email, you could be using IMAP or POP3 or SMTP. So there are different protocols or rules that are associated with each different type of application layer service. This chapter also gets into client-server model and also the peer-to-peer model. In a client-server model, we have a server which is going to host all of our resources. It could be files, it could be email, it could be any type of resource that you need to access over the network. The client then is the hardware or software that we use as humans to connect to that server and get those resources. So for example, on the right hand side here, we have a telephone, PDA, or a computer. If we want to download a file, get that resource, get those files, we would connect to it over the network, and we're now the client connecting to the server. Again, the server hosts all the information, and the client would request that. If we're running a client-server model, servers can have multiple connections at one time. For example, here we have 3 different Telnet connections going to one server. It wouldn't be very feasible to only allow one connection. Let's say you had an email server and you had 200 employees in your company. If you only allow one person to connect and get their email, it would be a pretty slow process. And what we're going to see in a future slide is these are called SMB blocks. However many SMB blocks that you have or that you're allowed, you will be able to connect to and get. This slide here is peer-to-peer networking. In a peer-to-peer network, your computer or whatever you're using is going to act as both a server and a client. For example, here they're sending instant messages back and forth. In that instant message, you're able to send information and you're also able to receive that information. If you ever used Kazaa or Morpheus, whatever other type of MP3 sharing programs that are out there, that's a peer-to-peer network. Your computer can host those music files and share them out, or your computer can also go out there and download computer files. It's not a one-way street, kind of like the client-server model is. You have communication back and forth, send and receive at the same time. DNS is a huge protocol that works at the application layer. Every time we go out to the internet, our computer takes that web address that we type in and it translates it into an IP address. Computers remember numbers. Every single website that is out there has some type of number or IP address associated with it. The reason we developed DNS is it's easier to remember Cisco.com than it is to remember 198.133.219.25. If you think about it, let's say you just created a new website and you called that website search.com. It's easier to tell your buddy, hey, go out to my new website search.com, than to say, hey, go out to my website 192.168.3.4. When he gets to his computer to type in that address, he's not going to remember that. He's going to remember the word search.com a lot easier. HTTP is another huge protocol that works at the application layer. This is how we get web pages. We request pages. The HTTP server will respond to that request and serve up that web page to our client. The reading gets into a little bit more detail on this. The one thing that I want to point out is whenever you type in an address, you have that http://. And what that is doing, that's telling your web browser that that's the protocol that you're going to use. If you wanted to access an FTP site, you would type in FTP:// whatever the site was to download files. So that HTTP is telling us we want to use the hypertext transfer protocol to access a web page. And when that server sees that it's an HTTP protocol coming over, it knows that it wants a web page to serve up. Email, another huge service that runs at the application layer. This is actually one of the questions on the online test and in the study guide there is the MUA, the MTA, and SMTP. I don't really expect you to know the specifics of this. Cisco wants you to know it for the online tests. But your MUA is just your mail user agent, whatever type of program you're using to send emails, whether it be Hotmail or Outlook or something like that. When we send an email, we're always using SMTP. Anytime we send emails, we're using SMTP. That message may get transferred to an MTA, a mail transfer agent. That mail transfer agent will take a look at that message, see where it needs to go, send it on along, and we're sending information again, so we're using SMTP. Again, SMTP for sending. It would finally get to the mail delivery agent, the MDA. That MDA would take that message and deliver it. When we're delivering email from a server or the MDA, we're going to be either using POP or IMAP are the two most popular protocols. So what I want you to get out of this is when we send emails, we're using SMTP, and then when we deliver those emails, we're going to be using either POP or IMAP or maybe like an Exchange server or something like that. So SMTP, always sending, POP, IMAP, that's delivering. Telnet will allow us to connect to a computer remotely or maybe connect to a server remotely. One of the most popular ways that we use it in Cisco is actually to connect to routers or switches remotely, and you'll see this a little bit more in the later chapters and also in the second semester of Cisco. Basically what it allows you to do is to connect to another computer remotely, but use your monitor, your keyboard, and your mouse at your computer to access the resources on another computer. SMBs, server message blocks. This allows us for file sharing and for printer sharing and to access any resources on a server in a Microsoft-based network. For example, if you have just a Windows XP computer, with a Windows XP computer you're allowed 10 server message blocks, which means that 10 clients can connect to your computer to access a printer or a file share or anything that you have shared out on your computer. With a server, you're usually given more than 10. Usually how many people you have in your corporation is how many server message blocks that you're going to be allowed. And again, what it does, it just allows us to connect to that computer to access a resource. This here has to do with a little bit of peer-to-peer networking. A lot of times with peer-to-peer networking, you have to have some type of service or program running for that peer-to-peer network to access properly. Kazaa, at WinMX, you all have to download a program that allows you to be on that peer-to-peer network. And that's just kind of what this slide is showing and what the pages in the online text are talking about. A little summary here. This chapter is mainly about the application layer. This is going to provide the network services to end users, to the humans. It's the closest to us. We see these applications, we see these services more prevalent than we do in some of the other layers of the OSI and TCP/IP model. Some of the well-known applications or protocols that we've seen: HTTP, DNS, server message blocks, DHCP, SMTP, and POP. Some of the peer-to-peer applications, we do have to use a different type of specialized program or software, and maybe with that program or software we have a special protocol that's running also.